Okay, 6.5, day 1, we're doing properties of logarithms. Okay, we're gonna let b, m, and n be positive real numbers. The reason is because we can only log positive values. We want the space to be positive so that if I do something to some power, it stays positive. Okay, we're gonna learn two properties. The first one's the product property. Logarithms are exponents. So if I multiply two monomials with the base of b, I add their exponents. So if I do the log of a multiplied argument, I add the logs. It's because I add the exponents, I'm adding the logs. Okay, if I have two monomials with the base of b, and they're being divided, I subtract the exponents. Since logs are exponents, I'm going to subtract the logs. Okay, normally we either expand or we condense, depending on what is convenient and what we're trying to do. So let's look at these, and then we'll see what it means when it says expand or condense. Okay, the first one says expand. When it says expand the logarithm, they're going to give me a single logarithm. They want me to write it as a sum or difference. There will be no exponents when I'm done. Everything will be written out. Okay. So I'm going to look at the argument. The argument is the x, y, z. So I said I'm doing x times y times z. So the product property means if I'm multiplying my arguments, that's the same as adding each of their logs. So I'm going to rewrite this as the log base 6 of x, and then I multiplied by y, so plus the log base 6 of y plus the log base 6 of z. They all keep the same base, but now I have expanded this as much as I can into the sum of 3 logarithms. And there will be times when this is more useful to deal with than that small logarithm. Let's look at the next one. Okay, this is the log base 4 of 5 over 7. Since these are being divided, I expand by subtracting each of the logarithms. So since there's a 5 at the top, I'm going to do the log base 4 of 5. Since the 7 is at the bottom, I subtract the log base 4 of 7. Okay, I'm subtracting because if something's at the bottom, it has a negative exponent, so it has a negative log. Okay, we're going to do the same thing. They're just going to get a little trickier. Okay, I'm going to expand this one. So they're all log base 2s. Okay, I start with a 3. The 3 is at the top. Okay, and I times the 3 by a p. So I'm going to add log base 2 of p. The n is at the bottom, so I'm subtracting the exponent, or subtracting the log. Okay, so this is my expanded form. Every time I subtract, it's like having a negative exponent. If it's at the bottom, it has a negative exponent. Okay, one more. This is log. It does not indicate a base, so it's common log. So all of these will be common log. If I start, I'm just going to start in the numerator. So the log m. It's positive log m because it's in the numerator. Okay, in the argument, I'm dividing by 4 to the 6, so I'm going to subtract the log of 6. It's at the bottom, so it's subtracted. Okay, now I know I'm timesing the 6 by n, but the n is at the bottom, so it's also being subtracted. If it's at the bottom, it's being subtracted. And then there's also the p, so I'm going to subtract the log of p. I know they're being multiplied. The 6, n, and p are being multiplied, but since they're all at the bottom, they have a negative exponent, so it has a negative log. Everything at the bottom is subtracted. Okay, let's add one property, and then we'll do a little more expansion. Okay, the next property is if I do the log base b of m to the n, I can bring the power down to the front and it'll turn into n times log base b of m. So I'll show you on this one what we do. Since it's log base 3 of n to the 4th, I can bring the 4 down to the front. So I get 4 times the log base 3 of n. Okay, and sometimes this is a more useful format than the other ones. Okay, now we're going to add that with our expansion. It's going to add more steps to us too, though. Okay, so I see the ln of x squared y to the 7th. I want to expand it. Okay, the first thing is I'm going to expand with this and this. So this is the ln of x squared plus, since it's being multiplied, the ln of y to the 7th. Okay, when you expand, you don't leave exponents. So the next thing I'm going to do is I'm going to bring the exponent down. So I'm going to have 2 ln x plus, and I bring down the 7 ln y. Okay, this is like a shortcut. Okay, this could also be, this is really x times y times y times y, about 7 times. So I could expand this and say this is ln x plus ln x plus ln y plus ln y plus ln y plus ln y 7 times. So instead of writing that out, we say there's 2 ln x's, and I would add 7 ln y's. So it's just a shortcut. Okay, let's try some trickier ones, and then we'll condense. Okay, so these are all log base 4, so let's start with log base 4. When you expand every single factor, so I'm going to start with the 5, it's at the top, so it's positive. Then I get to the x to the 4th, so it's log base 4 of x to the 4th. I see it has an exponent, but I'm not going to worry about it next, I'm going to worry about it later. Okay, the 7 is in the denominator, so I'm subtracting the log base 4 of 7. Okay, this looks really good, except I know I can't leave an exponent in the argument of a log. So even though this part's good, I need to bring down the 4 so that it's fully expanded. Okay, and then this is a good answer. I broke up every single factor and I brought down the exponents. Okay, one more expansion. What is this? Log base 8. Okay, I'm going to start it with the 7. The 7's at the top, so it's going to be a positive. Okay, now at the bottom I have m squared, so I'm going to subtract the log base 8 of m to the 2nd. At the bottom I also have n to the 4th, so I'm going to subtract the log base 8 of n to the 4th. Or I could subtract log base 8 of n 4 times. Okay, this looks good, except I know I cannot leave the exponents when I expand. So I'm going to bring the 2 down. And then for the last one, I'm going to bring down the 4. Okay, and then this is fully expanded. I separated every factor in the argument, and I brought down every exponent. Okay, now we were expanding on example 1. Now we're going to be condensing, which means our final answer is going to be the log of something. And I will only write the word log once. Okay, so I have the log base 2 of 5 plus log base 2 of 7. So my answer is going to be the log base 2. Since I'm adding the logs, I must have been multiplying the argument. So this is log base 2. I must have been timesing these together. And then just to make this simplified, I'm going to rewrite this as log base 2 of 35. Okay, and now I've written it as a single log. I have actually only written the word log once. So my answer is going to be the log of something. Let's look at the next one. Okay, this is the log base 6 of 7 minus log base 6 of 11. Since they're both log base 6, I can condense this. If I'm subtracting, then the 7 must have been at the top and the 11 was at the bottom. Does 7 divide by 11? No, then this is a good answer. Okay, let's try the next one. Okay, these are log base 4, they're all like base 4, so we can condense this. Oh, we got pluses and minuses. Okay, so the x is positive, so it's at the top. Plus log base 5, so times y, minus log base 4 of 7, divide, not 4, z. So I get the log base 4 of xy over z. And then my answer should be the log of something. Okay, D, what are these? These are all the log base 3s. My answer will be log base 3. Okay, I see there's subtraction, so there's going to be a fraction. Let me just get ready for it. Okay, log base 3 of 7, that's at the top because it's positive. I am minusing the log base 3 of 2, so the 2 is at the bottom. I am also subtracting the log base 3 of m, so the m is also at the bottom. Okay, and then that does not simplify, so that's my final answer. That's a simplified answer. And my answer is the form log base 3 of something. Okay, now E, I can't have the 6 here. I want to write this as the log of something and the 6 is in the way. So I'm going to use the power property and I'm going to put the 6 back up where it was before. So this is going to be the log of x to the 6th. Okay, same for the next one. I want to write this as the log of something. I can't have the 4 there. So let me give the 4 back to the exponent spot. Okay, now that I'm doing the log of x to the 6th plus the log of y to the 4th, now I can write it as a single log. Since they're being added, the logs are being added, I am multiplying the argument. So it's x to the 6th, y to the 4th. And it's okay to leave it like this. Sometimes we put parentheses to make it clear that you're logging the whole thing. But my final answer should be log of something. Okay, a couple more. Oh, I see the 2 here. Can't have it. Let me put it back up in the exponent spot. Okay, Okay, is the next one okay? The next one's okay. The next one has that 3. I don't want the 3 there if I'm writing a single log, so let me put it back up in the exponent spot. Okay, now I can write my answer as a log base 4. Okay, I see pluses and minuses, so it's going to be a fraction. Okay, the p is second up. I'm plussing the log base 4 of n, so the n is on the top. I'm minusing the log base 4 of z to the 3, so z to the 3 is at the bottom. Okay, 2 more. Okay, so let's see. Oh, 2. It's a problem. Let's move it. Okay, next one's okay. Oh, this one's okay too. Okay, let's rewrite it as log base 3. Okay, I see pluses and minuses. It's going to be a fraction. Okay, so the 5 squared is at the top. The 2 is at the top. Since I'm minusing the log base 3 of 10, the 10 is at the bottom. Since this is all numbers, we should simplify this. What is 5 squared? 5 squared is 25 times 2. 25 times 2 is 50 divided by 10. Do we know 50 divided by 10? Yep. So this is actually the log base 3 of 5, which is actually a much, much nicer answer than the original expression. Okay, last one. These are all natural logs, which is great. This 5, though, I object to the 5. So let's move the 5 back to the exponent spot. Minus ln 2, and then same that 3. We don't want it there. Move it to the exponent spot. Okay, let's rewrite this as a single natural log. There are pluses and minuses. There's going to be a fraction. Okay, so x to the 5th is positive. Minus ln 2. The 2 goes on the bottom. Plus ln of 4 to the 3rd. 4 to the 3rd goes at the top. If there's numbers, we should simplify it because it probably comes out nicely. What is 4 to the 3rd? 4, 16, that's 64. Okay, I'm going to put it first because it looks weird to put it second. So 64x to the 5th over 2. Is this a good answer? Oh, it's not done though because the 64 divided by 2 is 32. So my final answer is the natural log of 32x to the 5th. And that looks very condensed into one single log.